Hi y'all. In this video, we're going to go through a few examples of categorical syllogisms using the Venn diagram method to determine whether or not those syllogisms are valid. So this is sort of more or less what you can expect to be doing on the exam, where you get the argument. You have to identify the terms, rewrite the argument in its general form, and then use a Venn diagram to determine whether or not that form is valid. So we got 4 of them today. There'll probably be another video a little bit later on that where I do some more examples. But for now, this should get you started. Okay, example number 1, step by step. We're going to talk about how to do the Venn diagram method when you're given an argument. So on the exam or in your exercises, you'll get a categorical syllogism. It'll be in English. And just to briefly kind of run through what is the same about all categorical syllogisms. So they all have 3 sentences, 2 premises and a conclusion. They will all have 3 different terms. So in this case, cats, reptiles, and brown things. And those 3 terms appear exactly twice. One appears in both of the premises, but not in the conclusion. That's cats in this case, and that's the middle term. The minor term is the subject of the conclusion, so brown things, and then reptiles is the major term, the predicate of the conclusion. So the first thing that you do here is just sort of identify those terms. So as I said, in this case, the middle term is the thing that's in both of the premises but not in the conclusion, so that's cats. The minor term is the subject of the conclusion, that's the S, so S for subject. So in this case, that's brown things. And then the P is the predicate of the conclusion, the major term, and that in this case is going to be reptiles. So that's the first thing you do, is just identify the 3 terms, and then the second step is just to rewrite the argument with those substitutions. So premise 1, which is an E claim, I should just kind of put that somewhere just so we're clear what type of sentence it is no MRP. And then the second premise is an I claim, so it's a particular affirmative. That becomes some, let's see, MRS. And then the conclusion, which is a particular negative, an O claim, is some S R not P. So just be clear here that that is a particular negative. Okay, so those steps 1 and 2, those are pretty easy. But the challenging part is step 3, where you have to sort of draw a picture of the 2 premises and put that into this sort of 3-circle diagram. So the 2 premises in this case are a universal and a particular. So premise 1 is a universal negative, and so that's here. And then premise 2 is a particular affirmative, that's here. So what you do is sort of draw a picture of those, and just to kind of remind everybody about what those pictures sort of look like. With universals, you'll have an area that's sort of shaded in. And the universal sort of negative would have an overlap shaded in. So suppose we're just doing a two-circle diagram here, and we had to draw a picture of no M R P. What that would mean is this area is shaded in, which means that this area is empty, right? There's sort of nothing that is both an M and a P. So the trick, though, is to kind of go from that two-circle picture to the three-circle picture, and I'm just going to sort of show you how to do that here in just a second. But before I sort of move forward, let me just remind everybody that in situations like this, you always do, if you have a choice between a universal, which involves shading, and a particular, which involves drawing an X somewhere, then you always do your shading first because that indicates emptiness. And so what that means is an X couldn't go there. So here we got the, back to the premise one here. We're trying to sort of draw this picture, this sort of shaded overlap between sort of M and P. But we have sort of three circles, so that could be kind of confusing. But anyway, here's M, here's P, and here's the overlap between those two right here. And that's the area that gets shaded in. So this entire little overlap area, or this football shape on the right, gets shaded in. And note that there's kind of three football shapes here. So there's one on the left, there's one on the right, and there's one in the middle. We're shading the one on the right. Okay, so that's done. So we got the picture of premise 1. Now we want to do premise 2. That's the one that is a particular that involves drawing an X. So premise 2 is a particular affirmative. And in this case, the subject is an M, the predicate is an S. And what we need is an X in the overlap between M and S. That's what the particular affirmative looks like. So now, I'll switch up colors here so we can see the difference. Now, what we're looking for is the M circle and the S circle, right? And we're trying to put an X in the overlap between those two, right? So here's, I'm using blue, be a blue X in the M and S sort of overlap. So here's that overlap here on the left, and it just needs an X in it. Now, part of this overlap has been sort of shaded in, and remember that means sort of emptiness, so an X can't go there. So the only place for the X to go is over here in the left part of that football. So that's important, is that sometimes sometimes that, you know, one of the areas is sort of shaded in, and so the X goes in sort of the area that's available. But there are other times where both areas are available, and in circumstances like that, the X would actually go in the line between the two areas. So that'll come up in a later example, but for now, we don't have to worry about that. The X has to go here. It can't go in this middle area because it's been shaded. So there we have it. There's premise 1 and premise 2. So premise 1 is over here, shaded in. Premise 2 is this X that's in the overlap. And now it's time for sort of step 4. So step 4 is where you check and see if you have a picture of the conclusion. So in this case, the conclusion, which we're not going to draw in the Venn diagram, we're just going to draw it over here on the right just to see what it is that we're actually looking for. The conclusion is some S are not P. So S is the subject, P is the predicate, and we have a particular negative. So what we're looking for is an X that's in the S circle but not in the P circle, right? So it has to be inside the S circle but outside of the P circle. And if we have it, then the argument is valid. If we don't have it, then the argument is not valid. So let's look over here, see if we have this picture. I mean, we have a little bit more, obviously. We've got some stuff that's been shaded in. But basically, we just want to look at this X. Is this X where it's supposed to be? So if it's in the right place, it'll be inside the S circle and outside of the P circle. And if you'll sort of notice that, yes, right, here's this X, it's inside the S circle, it's outside of the P circle, it's where it needs to be in order for that conclusion to be true, right? The conclusion is that there's at least one X, excuse me, at least one S that isn't a P. So there it is, right? It's an S and it's not a P. So by drawing a picture of the premises, we've drawn a picture of the conclusion, and that makes the conclusion, or excuse me, that makes the argument valid. And I just gotta find my, there we go. So that's what we do. So we draw a picture of the two premises. If it gives us a picture of the conclusion, the argument is valid. If it doesn't give us a picture of the conclusion, the argument is not valid. Before moving on, I just want to say sort of one thing, that this argument where you have a premise that's a universal, another premise that's a particular, and a conclusion that's a particular, is one of the sort of few scenarios that actually sort of ends up with a valid argument. So there's actually sort of only two, and this is sort of one of them. In the next example, you'll see a different example. All right, so here's the second example that we're going to deal with today. This argument, I want you to notice, has all universals. So the premise here is a universal affirmative. The second premise is the universal negative, and the conclusion here is also a universal negative. So this represents a sort of the second type of categorical syllogism that even has a chance of being valid. The first type is where one of the premises is universal, the other premise is a particular, and the conclusion is a particular. Some of those turn out to be valid, and some of these turn out to be valid, where everything is a universal. So any other sort of combination, any other scenario that isn't these two, none of them are ever valid, and so we never actually deal with those. So you'll never see a situation, for instance, where everything is a particular, or where both premises are particulars and the conclusion is a universal, or both premises are universals and the conclusion is a particular. None of those are ever valid, at least not without making the existential fallacy, and thus you're only going to see these sort of two scenarios. So here's a scenario where everything is a universal, and so when it comes time to draw the pictures of the premises, we'll just be shading, right? We won't be putting an X anywhere. Okay, so just to go through the steps, first step is just to identify the terms. So S stands for subject. It's the subject of the conclusion. That's the minor term, so that's in this case useful things. P is for predicate. It's the predicate of the conclusion, the major term, which is action movies. And the middle term appears in both of the premises, but doesn't make an appearance in the conclusion, and so that's wastes of time. So that's first step. Second step then is just to rewrite everything with your SPs and Ms. So premise one becomes all PRM. Premise two becomes no MRS. And the conclusion is no SRP. So we always do that. If you do it sort of differently, it could still sort of work out. It's just that your picture will look different than mine, and it may be harder to interpret. But nevertheless, let's fill in with what we have. So in this situation where both premises involve sort of shading, it doesn't really matter which one you do first. So the order in which you do things only matters where when one premise involves shading, so one premise is universal, and then the other premise is a particular. And in this case, they're both universals, so it doesn't really matter. So premise one, I'll do this one in red. Um, Off to the side here, just to remind everybody what this is supposed to look like. So all PRM is a universal affirmative, so that's the A claim. And so what that means is you're shading in a crescent. So you see here P is our subject, M is our predicate, and the picture that we're sort of going for is, oops, is this, where this kind of crescent shape on the left, or the P part of the crescent shape, has been sort of shaded in. So again, that means sort of that it's empty. So assuming that it's true, what we just need to find that over here on our picture with the three circles. So here's the P circle, right? There's the subject of this sentence. Here's the M circle, that's the predicate. And then we need the crescent shape where like it's sort of M is taking the bite out of P. That's kind of what we're looking for, and that's over here, right? That's the crescent shape that we're looking for. And this is sometimes kind of tricky because there are, on these sort of three circle diagrams, there are 6 total crescent shapes that you could pick from, and so just got to make sure you get the right one. So anyway, this is the crescent that is empty, and so I'm just going to shade that in a little bit more, obviously, just to show that that area is empty, so nothing in here. Okay, so empty area number 1, and premise 2 also is an empty area. So in the case of premise 2, we have no MRS, so this is an E claim. And with universal negatives, we have overlaps that get shaded in, little football shapes that get shaded in. And so what we need is the overlap between M and S to get shaded in. So that's this football here on the left. And so it gets shaded in. And I should just mention, and I'll try probably mention again and again, that when you're shading in these shapes, make sure you don't stop at that third line, right? So, try to ignore the P circle here with this shape here. Make sure you get the entire overlap shaded in, because this middle part is part of that overlap. So that's empty too. And then same with this crescent, right? That's both areas on the left and the right are part of that crescent shape and are empty. So anyway, that's what your picture should look like. And again, remember, that's just what we do, or that's the only thing that we do is we just do the 2 premises. So the final step is then to check and see whether or not you have a picture of the conclusion, right? So you look at the conclusion. In this case, the conclusion is no SRP. So S is the subject, P is the predicate, and it's another universal. So if the picture's there, it would look like this. And in this case, what we're looking for is an area, this area, shaded in. So we want the overlap between S and P to be shaded in. And if we look over here at our 3 circle diagram, you will see that that is the case. So there's the overlap. You see the top of the overlap has been shaded in by the second premise. The bottom of the overlap has been shaded in by the first premise, but the entire overlap is shaded. So that means that this argument is valid. So once again, just like example number one, uh, drawing a picture of the premises has given us a picture of the conclusion, and thus we are done. Okay, so in the next couple of examples, I'm going to look at situations where we don't have that, right? That drawing a picture of the premises does not give us a picture of the conclusion, and thus the argument is invalid. So that will be the next slide. Okay, so here we are, example number 3. Here's an argument that is back to, or similar to example number 1, where you have a premise where, oops, my colors got all weird here. You have a premise where it's a universal, another premise that is a particular. So here's our universal affirmative up here. Then we have a particular negative, and the conclusion is a particular affirmative. So an AOI argument. And in this case, I think I mentioned in the previous example that this one is not going to be valid, that when we sort of draw the pictures of the two premises here, we're not going to get a picture of the conclusion. So moving on, the first thing that we do is identify our terms. So S for subject, the minor term, which is the subject of the conclusion, which in this case is cute animals. The P is the predicate of the conclusion, so this is happy, and I guess technically it should be happy things because we're talking about things. And then the M term, the middle term, is just the thing that's left over, or you know, the term that appears in the premises but not in the conclusion, and that in this case is babies. So the second step then is just to rewrite the argument. So all M R S, some M are not P, therefore some some S are P. Okay, so pretty easy first steps here, but the tricky bit then is to do the premises. Here's a situation where you have to make a choice of what goes first, because one of our premises involves shading, it's a universal, and the other premise involves putting an X somewhere because it's a particular. So in these situations, we always do the shading first. So that's premise 1. So premise 1 is a universal affirmative. It would look like this. All M are S. So the M circle is the subject, the S is the predicate, and for universal affirmatives that involves shading in a sort of crescent shape, right? This area over here is empty, right? All the M's need to be pushed into the S circle. So it's just a matter of sort of finding that on the 3-circle diagram, but it's up here. So all M R S. So there's nothing over here, nothing in these two, this area here. And again, remember, ignore that P circle here. You don't stop at that line. You got to get the whole crescent sort of filled in, because that's empty, right? If any part of that was open, that would be an M that isn't an S, but that's not possible, right? We're supposed to say all M are S. So that's our shading bit. And then we need to do some M are not P. So let me change colors here and talk about how that's going to go. So here, oops, that's a really terrible circle. Here's M as our subject, P is our predicate, and we want to say that there's at least one M that isn't a P, so that means putting an X in the M circle, but not in the P circle. So where is that on the 3-circle diagram? Well, that's over here, right? So here's the M circle, here's the P circle. We want the X in the M circle, but not in the P circle. But half of that has been sort of shaded out, right? Because of our first premise, we know that this part up here is empty. So the only place left that's still inside the M circle, but outside of the P circle is over here. So that's where our X is going to have to go. So there it is. Premise 1, premise 2, all sort of drawn out, and now it's time for step 4, right? To check and see whether or not that by doing that we get a picture of the conclusion, right? So if we do get a picture of the conclusion, the argument is valid, but if we don't, the argument is invalid. And so here is a situation where we don't get the picture. The conclusion in this case is some SRP, which would look like this. It would be an X inside the overlap between S and P. So if you look back over here in our 3-circle diagram, where we would need the X would be here in that middle football shape, right? That's where we would want an X, or that's where the conclusion says there should be an X, but there isn't an X there. There is an X, it's just not in the right place. And so, and that is not going to do it. So that means that it's possible for the conclusion to be false, even if both of the premises are true. So the argument is invalid. All right, so that's it for example number 3, and we'll move on to example number 4. All right, here's example number 4. Here's again, is going to be an argument that isn't valid or invalid, and just like example number 2, this is a situation where everything is a universal. So you have all universals, in this case, all universal affirmatives. So all cars are vehicles, all cars have 4 wheels. So all vehicles have 4 wheels. So first step is just to identify everything. In this case, our subject of the conclusion is vehicles. Oops. Our predicate of the conclusion is things with 4 wheels, or things that have 4 wheels. And the middle term, which is the thing that appears in both of the premises but not in the conclusion, is cars. So if you rewrite that, then the form that this argument takes is all M are S, all M are P, therefore all S are P. So drawing the premises time, remember that when both of your premises are universals, right, when both involve shading, it doesn't matter which one you do first. So we'll just go ahead and do premise 1. So all M are S would look like this. So we got to find our M circle, we got to find our S circle, and shade in the part of the M circle that isn't part of the S circle, right? So that's this area here. So that area is empty. And then premise 2 is all MRP. It's the same type of sentence, just different terms. So all M or P instead of all M or S. So it's going to look pretty similar. It's just going to be oriented different. So it's just another part of the M circle gets shaded in. Gets kind of, there's overlap, but empty is empty, so it doesn't mean anything if there's overlap. But that's it. So both premises are indicated, and now we need to do our check, right? So our final step is to see whether or not we have a picture of the conclusion. So just going to get my color here. What we're looking for is all S are P. So we're looking for this picture where this part of the S has been sort of shaded in, and if we look over to our 3-circle diagram, I'm just going to outline it here. This is what we would want to be shaded in, and you'll notice that some of it is right. The top part of that area is shaded in, but not the whole thing. And in order for this to work for the universals, when your conclusion is a universal, you need the entire thing sort of shaded in, but it's not, right? So half of it has not been shaded in, so that's not the picture. So that means that the argument is invalid. All right, well, that's going to be it for today. I'll probably come back with a video with some more examples a little bit later on. But for now, it's my hope that you have sort of enough to go on to work on the exercises in the textbook.